Hello friends, welcome to part 2 of solution of question paper Elements of Modern Physics C-9 4th semester, BSc 4th semester, Dibrugarh University 2022. Okay, so before we start, please subscribe the channel, hit the thumbs up button, also share with your friends and inspire me to create new contents for you and help me to grow my channel. Also hit the bell icon so that you get notified when new video will be uploaded, right? So now let's start. We have already solved up to question number 2 in the first part. Link is in the description box. So let's start from 3a. So here you are asked to state the Heisenberg's uncertainty principle and obtain the minimum energy of a particle confined in a one-dimensional box using uncertainty principle. Okay, let me give you the answer here. So here is the uncertainty principle, 3a answer. Okay, and just you have to start the statement from this italic line. Okay, and the proper calculation give you this result, right? So now the next part of this question, there is one more part, that is the obtain the minimum energy of a particle confined in a 1D box. So let me give you that answer. Okay, let me go to a new slide. Here is the answer to the next part of this question, not completed yet. Let me take another slide. So this is the last part of this answer. So here, final part of the answer. So just here you see, let me show you the answer again. From here you have to start, take the screenshot. So here it is. So let's move on to the next question. Now let's solve this 3b. Okay, here the wave function is given. This is the wave function. So the 3b answer, the given wave function is phi of x is equal to an sine 2n pi x by l. So here the given region is this: x is less than equal to l and greater than equal to 0. Okay, in the region, right? So here what we're going to do, we're going to use the normalization condition. So outside this region, the value of this function is 0. Okay, so now you see the total probability that the particle is somewhere in the box somewhere in the box, that means within this region, must be unity, right? That is the normalization condition here. 0 to L, integration 0 to L mod of phi of x square dx is equal to 1, right? So now let's put the function here. Instead of phi x, we're going to put this. So if you put this, then what you're going to have, let me copy these things and let me go to the new slide. Okay, just wait. Let me take copy of this part and let me go to the new slide. Okay, so now what we're going to have, 0 to L integration, here we're going to have a square. So that means here an square, this is an square, sine square 2n pi x by L. That's what we're going to have, dx is equal to 1, right? So here this an square is constant part. So let me continue here. So an square is taken outside the integral, 0 to L. Now here, using trigonometric identity, we can write this one as half within bracket 1 minus cos 2n pi x by L dx is equal to 1. That's what we can write. Okay, sorry, one more thing. Here it should be 4. Okay, so what is the identity that we have used here? The trigonometric identity that we have used here, that is sine square x is equal to 1 by 2 1 minus cos twice x. Okay, so instead of x we have 2n pi x by L, and if you put this here, then you're gonna get this result. Okay, so hope you have understood this. So this identity is used. Now let us integrate this. And integrating this, what we're gonna have here, half is taken outside, n square by 2, and integration of dx, that's going to be x, minus integration of cos x is sin x, right? But here we have this, so that's going to be equal to L by 4n pi into sine 4n pi x by L. That's what we're gonna have. So here the limit is 0 to L, so that is equal to 1. So here you see for the upper limit L, if you put here L, then these two gonna cancel, and 4n pi is the even multiple of pi, and sine of even multiple of pi, that's going to be equal to 0, right? So for both 0 and L, this part going to be 0. So in that case, so our result going to be equal to an square by 2 x, instead of x we're going to put L, and lower limit is 0, so that's why definitely it's going to be L is equal to 1, right? So that's what we have got, right? So we have to find the value of n, so that's going to be equal to an square equal to 2 by L. So an, that is nothing but root over 2 by L. So this is our answer. So hope you have understood this. Now let's move on to the next question. So here we have differentiate between nuclear fission and nuclear fusion. So what do you mean by mass defect? So let me answer this. So here is the answer of question number 3C, and this is the definition of mass defect. So take the screenshot of this and this. Okay, let's move on to next question. So let me clean this first. So question number 4. Now question number 4, write down the time independent and time dependent form of Schrodinger equation for non-relativistic particle. So I have already made a video and with proper explanation of on time independent Schrodinger equation. So link is in the description box. I have written in the description box time independent Schrodinger equation, then I have provided the link. Okay, just click the link and you can watch that video, then where you're gonna have the proper explanation of that equation. And time dependent form of Schrodinger equation is this. Let me write here. So that is minus a squared square by twice m partial second order partial derivative of phi with respect to x, then plus v phi, where v is the potential, and it's minus a squared by I, then del phi by del t, right? Phi is the wave function. So this is the time dependent Schrodinger equation, right? And energy and momentum operators. What are the energy and momentum operators? So I have already made a video on this also, energy and momentum operators. I have given the links in the description box. So what's that video? Now let me prove this relation. So let me give you the answer, proof of this question. So let me take a new slide here. So to prove this relation, we are going to start from here. So take the screenshot. So this is the relation. Okay, I'm not gonna explain this, it's too long, so I don't want to make the video very long. Okay, so I'm gonna explain those things in separate videos which will be made on this, purely on this topic, on this syllabus of quantum mechanics separately. So here this is only my motive is to give you answer only in this video. Okay, so let's move on to next question. So now in this question number 4b, either you have to answer this question or this one. So what will be the answer to this question 4b? So what is the probability of a particle related to the wave function, how is the probability of a particle related to the wave function, and obtain the expression for the probability current density. So let me show you the answer. So here is the answer of 4b, right? 4b or. So this is the answer. So hope you have understood this. And answer to question number 5 and 6, these two questions will be solved in the next video. Maybe tomorrow morning you're gonna have the answers, or tomorrow night you're gonna have the answer. Okay, so thank you for watching. See you in the next video, and best of luck for your exam. Thank you.